So before the break, we looked at GRIB tools for inspecting GRIB messages. So just for getting the information out of the GRIB messages. In this second part, we're going to actually start looking at tools for making modifications to the messages. So making simple changes to the headers or to the values, or making copies. So we're going to look specifically at three tools. The first one is called GRIB copy. This is you can use to copy selected messages from GRIB files to new files based on key values. So you might say, yeah, I can always copy a file. I can do the Unix CP and just copy file A to file B, and I've copied it. But this is a smart copy. So it has knowledge of the underlying GRIB, and you can say copy files, but depending on particular key values, only copy some messages, not all of them. You can actually also reorder the messages, a bit like you can do with the -B option in GRIB LS. The next tool we'll look at is GRIB set. This is where you can actually start to make changes to key value pairs, or at least the values of some keys that are already in the message. So you could, for example, change the param ID. You could change the data date. You can make changes like this, simple values, or you can actually also make modifications to all of the data values. So you can make global changes like multiplying all of the values by a constant value, or subtracting or adding a constant value to all of the data values. So you can imagine using that, for example, to convert the geopotential into a geopotential height, or changing degrees Kelvin to degrees Celsius, for example. These might be two changes you make globally to all data values. And finally, we'll touch on a tool called GRIB to netCDF. This is used at the moment by the Mars Web API, which you may have tried out yesterday. If you request format equals netCDF, Mars Web API underneath actually calls GRIB to netCDF to convert the GRIB into netCDF. There's a caveat with this. The GRIB fields have to be on a regular grid, so you have to have them on probably regular lat long is what you would have. This grid type of grid equals regular LL, or a regular Gaussian grid, so regular _GG. It will not work if you get the spherical harmonic data out of Mars, and it will not work if you get the data on the native octahedral reduced Gaussian grid or any other reduced Gaussian grid. But it works as long as it's a regular grid. As I say, it's used by Mars Web API to provide the data for in netCDF if you specify format netCDF. Now, talking about GRIB set, I want to put this warning up to start with that there are some things you cannot do. So you may have got data out of Mars in the course yesterday, and you may have accidentally forget to put a grid equals in your request when you're getting pressure level data, for example. And what you get then is the data in spherical harmonic format. So you get the spectral components. And you might be tempted to say, but it's just the grid type that's different here. I can do GRIB set grid type equals regular _LL, and I've got it on a regular grid. No, this does not work. You can do it, but it doesn't change the format of the data. The data is still the spherical harmonic components. Similarly, you can't use it to transform the data from one grid representation to another. So you might have got the data on the native octahedral grid, and you want to use GRIB to netCDF with this, and so it fails, and you think, I've got to have it on a regular grid, so I will change the grid type of grid to regular _LL. Again, this will work. It might actually start to give you some errors now. I think you'll end up with something that you cannot even read because the number of points will be incorrect. The number of data values, the number of grid points you've got in the file will be incorrect. So again, you can have something a little bit silly. And you can't use it to make that transformation. Similarly, and this is a question we frequently get, is can we crop a sub area out of a global field, particularly with our open data where we provide only the global field, and people just want to crop a sub area out over, say, Europe or South America, wherever. And they say, okay, I can set this these keys, you've perhaps seen these latitude of first grid point in degrees, latitude of last grid point in degrees. And I just set those to be the area that I want, and then I get that area. Again, ecCodes will let you do this, and group set will let you do this. But again, the data will still be the global data, and all you have done is compressed it into this smaller area. And probably when you try to decode it, it won't work, because again, the area will probably have a different number of points into what you've actually got. So the story here is you cannot use the group tools to transform, crop, or regrid the data. You really need to use a regridding tool. You can use Mars to do that. If you have access to Mars, you can read the file in. Maybe you tried this yesterday as a source file, put a grid equals and write it out again. METView can also do this as a regrid function in METView if you use METView. Or this afternoon, you'll learn about something called EarthKit. And EarthKit also has a regrid module that you can use to do this regridding. So that's something that you cannot do with the group tools. So that's all we're going to talk about, really, about the group tools. I now want to just mention the API a little bit briefly, so that you can know a bit about that and go into that. So we have these user interfaces. So although the tools are really convenient for doing kind of basic manipulation of the data and getting information out of the group files, sometimes it's either more convenient or even necessary to write a program. And as I mentioned right at the start, the ecCodes library supports 3 user interfaces. So you have the C, which used to be the native C, and you can access it from C by including the ecCodes.h header file in your own C program. It has a Fortran 90 interface, so you have a Fortran 90 modules, which you can access with use ecCodes. Or the Python interface, you can just import ecCodes as the Python module. And we, in this course today, will concentrate just on the Python interface. But just to mention that I think it was on Tuesday this week, you did about compiling on the Atos HPC. So if you're working on the Atos HPC, we provide 2 environment variables which you can use for compiling your C and Fortran codes. And this is ecCodes_include and ecCodes_lib. And these are available when you do module load ECMWF toolbox. So you just do module load ECMWF toolbox, and then you can use these environment variables to compile and link your program. So here in C, my program is going to call myprog.c. It's going to have an include ecCodes.h at the top, and then I can set the ecCodes include as a variable here and link to the library via the $ecCodes_lib. And that takes care of making sure that all the linking of the shared object libraries is done correctly, so that you don't have to worry about that and you don't start messing around with the LD library path in order to get your codes to run. And similarly with Fortran, you can use it with gfortran, or if you're in the Intel compiling environment, you can use it for that as well. But with gfortran, again, you just use ecCodes include and ecCodes_lib, and that's how you use them. So when you're decoding using the API, we put together this general framework, which is kind of thinking about it with Fortran, because we used to teach this course with Fortran. We're now moving more to Python. But the first thing you need to do is you open 1 or more GRIB files for reading or for writing. With Python or C, you can just use the standard system open commands, open functions. But with Fortran, you have to use a routine provided as part of the library called codes open file. And then you need to load your GRIB messages into memory. You can load 1 or more, however many you need to load. And there's 2 main routines that are available to do that. Today, we'll look at something called codes GRIB new from file, which just reads the messages 1 by 1 from file and loads them into the memory from where you can access them. There's also another way, which is slightly more sophisticated, of using an index, which I'll not go into today. And what happens is when you call these routines, they provide a unique identifier to the location of the message in memory. So you don't have direct access to the GRIB message in the memory. You have it through this identifier, and it's that identifier you use to manipulate the loaded message, so to get and set the key values. And then you have a number of calls to, in this case, we're talking about decoding, to decode the loaded GRIB message. And you can only access messages which have been loaded. So you've had to have called codes GRIB new from file to load a message into memory. And then there's various calls called codes get, which allow you to access the keys. So this works a bit like GRIB get. It's exactly the same function. You do GRIB get, you pass this identifier and the key you want to get, and it returns you the value of the key. And the main message here is that you don't need to decode everything. You don't need to go through all of the different keys in a GRIB message to get the values for each of them. If you want to do that, you use GRIB dump. That exists. This is where you just want to perhaps get the parameter, perhaps the level that it's on, and the values. And then when you've finished with the message and you've got all the information you need from it, you need to actually release the loaded message. That frees the memory. Otherwise, if you keep loading more and more messages, you run out of memory. So you need to release the message. And then when you're done completely, you just close the GRIB files that you've opened. And again, with Python and C, you just use the standard system close function. Or in Fortran, you cannot just use a Fortran close, you must use codes close file. So here's a little example of how it looks in Python in one page. So here I'm importing everything from ecCodes, so I can just use the function routines directly. I load the message from a file. So here I'm loading actually says file.grib1 in the comment, and I'm actually loading file.grib2 here, I can see. And then I'm starting a loop where I have calls in the loop to codes GRIB new from file. It points at the file I've opened, and I create this GRIB handle or this identifier called iGRIB. And when I hit the end of the file, iGRIB will be set to none. So then I can drop out of the loop and I close the file. But if I get an iGRIB back, I can then use that iGRIB, passing it to the codes get function, and I pass the keys that I want. So I want to get date, and I put it into a variable called date. I want to get type of level, and I put it into a variable called left type, etc. I'm also getting here level and values. And the only difference is when it's an array that I need to get, I call codes get array, so that it passes it back. So the values go into an array. And this is a 1D array. Even if the data is a 2-dimensional, you get a 1D array back. So you then have to put it into the 2-dimensional array if you want it in latitudes and longitudes. And then I'm just printing these out. And then the important thing, within the loop, I've finished with this GRIB handle and this identifier, I release it, and that frees the memory. Now I could have an iGRIB1 and an iGRIB2, and I could open 2 messages at the same time, even from different files if I want to work like that. But that's basically the framework that you need to use in Python. Now, I think very few people these days are really going to be using the Python directly. I mean, some people might, but we have some other tools and packages that can be used. So one of them is cfgrib. cfgrib provides you with a Python interface to map GRIB files to the netcdf common data model. And this follows this CF convention, and it uses ecCodes underneath to do the decoding. So this was done in collaboration with a third-party software company. It provides high-level access using what's called an engine called cfgrib as an option that goes with xarray. So what you do is you get an xarray data object back. And the whole thing was inspired by the netcdf4 Python and H5 netcdf, but using ecCodes underneath for low-level decoding. So you can install this from Conda or Pippy, and again, it's on our GitHub for open development as well. And there's a little example here how to do it. You can see all I'm doing actually is importing xarray, and then I do open a data set using this engine cfgrib. And then when I print the data set, I've actually got the GRIB data that I can access. Now, CFGRIB is kind of gradually being replaced. We've got a new package that is being developed called EarthKit. And there's a part of EarthKit called EarthKit Data, and you'll learn more about all of this afternoon from Shandor and colleagues. So EarthKit Data is providing a format agnostic handling of geospatial data. So it's not just for GRIB, it'll also handle NetCDF, buffer, and even some of the data formats used in hydrological services as well. What it does is it abstracts the GRIB files onto an array of values together with a dictionary-like set of metadata. And then you can access this as a set of fields, list of fields which have been converted either to NumPy or to X-ray or Pandas data sets. Again, this is available on Pipi. So you can just do a pip install of EarthKit Data. Code's all on GitHub. I've given you a link here to the documentation, but you'll learn much more about this afternoon. And here's a quick example where you can just do from EarthKit in Data. I'm just importing one part of it called from source. I open a file, and then I've got this returns me I've got a file name here. This is one of our open data files, I think. And then I get the data set back by calling the file. EarthKit is actually particularly nice because it can also call Mars directly. You can give it a URL, so you can download the open data directly, or you can point at any file where there's a URL. So EarthKit's a very nice way of working. I think this is probably going to be the way forward for most people who want to be playing with our data in the future. And I think with that, just to finish off, ecCodes can actually do a lot more, because the idea is to provide a set of high-level keys and subroutines to derive and compute extra information from a loaded GRIB message. So even from the API, you can get keys, you can get the average, the minimum, maximum of values. You can get a list of all of the latitudes and a list of all of the longitudes. You can even have a routine which is called codes GRIB get data, which will return you the latitude, longitude, and values, a bit like this triplet that you were seeing with the GRIB get data tool. It's working in exactly the same way. You can call that from your Fortran, C, or Python program. There are also routines to extract values of points. So there is a codes GRIB find nearest, which will get the data at the closest to a given geographical point. So this is a bit like doing the GRIB ls minus L. And you've got the codes get element. So this is like doing the GRIB get minus I to get a particular index point from the file. And those are also available through the API. Again, this is probably all being replaced gradually with the move to Polytope, which I think you heard about earlier. But that's available if you're writing your own codes. And then finally, there are routines for index access, as I mentioned. This can be much faster than making sequential access because basically it allows you to go randomly through the file. So you build an index first, and if you're only interested in all of the parameters at 1,000 hectopascal pressure levels, then you can jump through the file to each one. And that's much, much faster than reading each one, checking, have I got the parameter on 1,000 hectopascal? No, go to the next one. So that's a way to do it. And I think we have a little bit of documentation on doing this. So just to summarize, basically, yeah, we've got an API, but it's not always necessary to write a program. In old decoding software, we used to have people writing Fortran programs to do a GRIB ls effectively. We have now tools, command line tools, which you can use. And we recommend you use those where you can, rather than writing your own program. Use the edition independent keys where you can, because that just provides you with this transparent access to GRIB1 and GRIB2 messages. And finally, yes, think about how you need to access the data in the GRIB messages and how, the different messages in a file, because sometimes this index access can be much, much faster than making sequential access, particularly if you've got a lot to do. So I think with that, I am done. I'll just ask if there are any questions on that before I pass over to Yigit for the demo. Don't see anything in the chat. No hands going up. So perhaps, Yigit, if I stop sharing and you're going to demo the GRIB copy, GRIB set, and GRIB to netcdf, and a bit about the Python as well, I think.
Absolutely, yeah, those four. So I'm sharing my screen. Okay. So we are now in the second demo, which, just like Paul said, I'm going to show GRIB copy, GRIB set, GRIB to netcdf, and the Python API. The Python API part will be super fast. It will be just me running a super simple script so that we know it works, kind of. So first, where am I? I'm still in the demo folder. So you have all the links. So please go there, and we will start with GRIB copy. So what it does is it simply extracts or copies the content of GRIB files with your -w flags, for example. So it takes whatever you, so from your input, it takes the messages containing your input simply, and then creates a new file. So that's the main function of it. So what we can do with it, so I can just do GRIB copy and then -w. So now, for example, I can use any key I want. I would like to use now edition 1, but just before that, sorry. So to see the file, so that what we are expanding or what we are extracting, let's say. So here is the file, for example. So here we can see there are 5 messages. So if I do GRIB copy -w edition 1, and then the input file. Now I would like to, I need to pass an output file, which will be created from scratch, kind of. edition1.grib, let's say. So it's there. Without checking edition1.grib, I would like to do this so that we create, we created edition1.grib. Now we are creating edition2.grib as well with edition 2. So now what I can do is that I can check edition 1 grib and edition 2 grib. So here we were having 5 messages. 2 of them were edition 2, grib 2. The 3 of them were edition 1, and we have now 2 files, edition 1 grib and edition 2 grib. Edition 1 grib has 3 messages, which all edition equals to 1. So 3 messages in edition 1, 2 messages in edition 2. So this is how we can simply separate messages between them. So for example, it would do the same if I pass -w, but not edition, but type of level, for example, because 3 of them is surface, 2 of them is hybrid. So this is generally how it works. Here I actually would like to show one functionality of GRIB, not actually ecCodes, but I would just like to show it. So if we do cat, if we use cat command and then do edition 1 grib, edition 2 grib into, for example, I don't know, edition 1 plus 2 grib, it would simply merge these two. And if we do grib ls edition 1 plus 2 grib, it would simply show the same. And actually we can use grib compare between a1 file and then edition 1 plus 2 file, which would show if there is any difference between these 2 files, which would show something. It doesn't show anything, so it's these 2 files are simply the same. So now what we can do with the GRIB copy, but first let me remove this edition 1 and edition 2. I hope I didn't remove any other. Okay, so what we can do next, again, use GRIB copy, but and put the input, and then put the input again. Now I will edit the second one. So I will now edit the output. So what I can do is, now I can do short name like this, and in double quotes. So this would simply create a number of files, and each one will have A1 blah blah underscore its short name. So number of messages. So let's run it. So it did the trick. You can see that. So this was the input. We have these 5 outputs because we had 5 messages with different short names, and you can see those short names we have. For example, if I do A1 and then T, it shows you only one message with the correct short name simply. Okay, this was it. And then what we can do is that you can also, of course, export. So if you do grep copy and then -w and then count equals 3. So this would extract the third message. But of course, you also would need an output. So if you do this and if you check grep ls3.grep, you would see the third message here as a standalone file. Okay, so grep copy is done. We can now switch to grep set. Just I can just remove this stuff. Okay, and then also this one. Okay, now it's clean. Now we can go to grep set. So grep set is simply we are modifying the values, the key values. But of course it. But yeah, I will now show you how it's working. So it starts with actually here first. I would like to do a quick grep ls so that we see what's inside the original file. So I'm now using this file. So we can see that there are 6 messages and it's all, let's say, recent files. The base date is here. And now we can do grep set, and then I will directly put the input. And then actually I will also put here the, no, let's do it in the later, so that I will start the command with -s, so that it's now in the set mode, let's say. And now what I would like to change is the date, which is so for demo purposes, it's fine. For other purposes, not so much. But I can do something like 1775, 17th of October. Yeah. So something like this, for example. And then I can also change one more thing, would be step range, for example, 99999. So then I need to do now the output. Output would be time travel, that grep2, so that if I run this, it worked, as you can see. Now if I read time travel.grep2, you would see that we have a step range as 9999, and date is pretty old. So so here is how grep set is working. But of course, I mean, as you can expect, it didn't change the values. So kinda you have to be kind of careful using this program. What we can do now again use GRIB set, but now maybe we can use not date and step, but maybe use, for example, short name equals T, and then so now we, sorry, not like this. So we use -v so that we tell GRIB set first find where the short name is T, and then -s, and now we will change this to short name PT, for example. So from temperature to potential temperature. So, and of course, I would like to change the output, which we can do out pt.grip2. I'm just checking if I missed anything. It should be fine. So let's run it. So if I do a simple grip ls on the output, you can see that we changed from T to PT. So this is simply how it works. We can also check actually with the namespace parameter. So if we do that, you can see that it changed param ID and also the name, for example, not only the T to PT, but also the name and param ID as well. Okay, if I clear everything. So now I would like to switch to GRIB to netCDF. This is, as Paul says, this is used in Web API, for example, Mars Web API. So it's simply you input a GRIB file, it outputs a netCDF file, but you have to be careful on a couple stuff. So it should be reduced Gaussian grid simply, and sorry, vice versa. It should be regular lat-long or regular GG. Okay, so that's a tricky thing. So so if I would like to first start with a quick GRIB copy so that I have the input for to use GRIB to netCDF. If I do this and then input one of the open data files, so it will just extract this into 1.grib file. If I just check what's in the file, it's this file simply. So it's regular lat-long. Then simply I will just run this command. So grip to netCDF. Then I pass -o, which is output. Output is netCDF, that's why it's .nc, and then the input, which is 1.grib. If I run this, it simply processed one grib file. It found one message, and it simply extracted it. So if I do this command, nc dump out 1.nc, and we are only seeing the first 60 lines, it would simply show the temperature in a netCDF file simply. So this was how you can work with the GRIB to netCDF. Now, as the fourth and last thing, I would like to show the Python API. This will be super basic and super fast. So first, I would like to go to, actually I have the Python in the demo folder, but I would like to go to Python folder here. Sorry, it's cd Python, of course. So I can see that we have ecCodes _ demo.py. So first I would like to show you, scroll up a bit. So first we start with importing all available functions of ecCodes library. And then we define a function, which is called codes dump. and then we use different functions to simply iterate all the fields. And then we simply dump all the messages. So I will just clear everything here. And then since I'm under Atos HPC, I would like to, I need to use model load for loading Python. So I will do model load Python 3. Now I'm able to use Python, and if I do Python 3 ecCodes demo, it will simply dump the file using ecCodes Python API, and simply this is how it works. So of course it's there are many features on in Python API, but it's not our focus today. So this was it from my hand side.